Hello, and welcome to this video about Red Hat Advanced Cluster Security. Today, we're going to be talking about working with the ACS RESTful API. I'm Chris Porter. I'm a Senior Principal Solution Architect with Red Hat. So we're going to start with an introduction to the ACS API and talk about some of the use cases that you can accomplish with it. We're going to talk about how authentication is required for the API and how to authenticate. We'll give you some basic API examples, including some use cases like retrieving data from the API and changing the ACS configuration using the API. And then lastly, we'll talk about some advanced topics like pagination of data returned from the API and exporting data in bulk. To start with, the API for ACS provides programmatic access to all the product features. So for the data retrieval, for configuration, everything that you see in the UI is done through the API. And so you can do anything that you see in the UI with the API. The documentation for the API itself is available through the ACS web user interface. And we'll take a look at that a little bit later. The ACS web UI I mentioned, and also the rockctl command line, both use the ACS API to do their work. So when you're thinking about tasks that you're going to perform there, remember that everything that you can see in the UI is ultimately achievable through the API. Now, some really common use cases that we see that call for the API would be, for example, exporting data and transforming some of the security event data that we have in ACS into other formats or sending it to other tools. So the data here can be extracted in bulk or individually and can be pushed into other tools that would import that. You can also manage configuration externally. So for things like integrations and auth and especially policies, you can store those externally as JSON objects and import them. So some really common cases here would be to, for example, export ACS policies from one instance of ACS and import them into another, or actually maintain and modify them externally and have them pushed into ACS using an API task. Another use case is to schedule periodic tasks. So things like compliance scans or scheduled reporting or backups. Although note that most of those use cases can actually be done with the product today natively. And a lot of capabilities like backing up ACS can be performed through rockctl. So there are a lot of cases where using rockctl is the better choice just because it's easier to automate. And what I'm saying is consider carefully whether or not you really need to use the API, which is going to be a little bit more complex than just using something like rockctl to accomplish what you need to do. The API endpoint is hosted on your central host name. So whether this is cloud like we have here, or it's a self-managed ACS installation, the same browser interface, the same URL that you use for the browser interface is going to be the same path for the API endpoints. And they all start with /v1 or /v2. This is an example of the ping endpoint. Now, every endpoint is going to support a couple of different, or one or more HTTP verbs. They're not all going to be the same. Some of them do not support modification. Some of them are only going to have a get verb available, but the ACS API documentation will show you what verbs are supported for each endpoint. One thing that is consistent is that it's always a JSON format. So all data that you're sending to ACS and all data that you're going to get back from ACS is natively in JSON. Good practice here would have you setting the appropriate HTTP MIME type headers, but it's really not necessary because as long as you assume it's always JSON, you'll be all set. Generally, authentication is required for all API actions. The ping example here is actually one that doesn't, but almost everything else is going to require authentication. And authentication is performed via StackRock's API tokens. And we'll take a look at those in the next slide. But your API permissions are going to be determined by the role assigned to that API token. So that in turn will affect which HTTP verbs you can use on that particular API endpoint. So if I assign an analyst role, which is a read-only role, I'll only be able to perform a get operation on HTTP verbs against those API endpoints, and I wouldn't be able to use, for example, a post or a delete. So you can create those API tokens, and these are the same that you would use for rockctl. You can use the UI to create these. You can actually use the API to create them as long as you already have some level of permission to create tokens. Every token has a lifespan. If you don't specify one, it'll be 1 year by default. And the role must be specified as part of creating that API token. You can use a built-in role. You can use a custom role. Good practice here is least privilege. If you know that you're just going to be retrieving vulnerability data, then all you need to do is give read data to the images object, and then you'll be able to retrieve image data from the API. The API tokens can be revoked by deleting them. And then the usage of the API token is pretty simple. It just uses a bearer token. Here's a curl example where I'm providing this as part of a header that just gives the bearer information. I've got my API token here in a variable shell variable called rocks underscore API underscore token. And this is a pretty common way. RocksETL uses the same variable for its API token as well. The API documentation is hosted in the ACS UI, so you have to have access to the central interface on an ACS instance in your environment or hosted on Red Hat Cloud. That UI is it has both a that API, sorry, has both a V1 and a V2. They're not replacing one with the other. There are certain endpoints that have a second version of them now for new functionality, but mostly you'll be looking at the V1 API reference. There are examples of the usage of the API shared in a GitHub repo here. So we collect examples of useful utilities and scripts and configurations and keep them in this repo. And there are all of those utility scripts use the API in some way. So check there to see if there's already examples of how to accomplish something that you might be looking for. Another good reference to understand is to kind of spy on what the ACS web UI does by using browser web developer tools, where you can look at network payloads, see the requests being made, understand the arguments, the parameters, and the structure of the data that's being returned. Next up, we'll take a look at the API reference and creating authentication tokens for the API. And here in the ACS user interface, in the upper right-hand corner near my login name, you'll see the help menu, which brings a couple of items up. The API reference for V1 is what we're going to be looking at. V2 is just a couple of new API endpoints to support new functionality. If you look at the reference here, you'll see that it's in this Open API spec format, and all of the API endpoints are laid out in the same way, where there's a detail of some of the query parameters that are supported. On the right hand is a sample of the path for the API endpoint, as well as an example of the data that's either returned or submitted as part of it. If you take a look at something like the alert service, now this is important to note that there's an API endpoint at /v1/alerts. It's called alert service, but this is actually the violations section of the UI. So the UI uses the phrase violation. The underlying API uses the term alert. There are a couple of others that are like this, but this is the big one that's often easy to confuse. You'll see that the alert service is laid out like a lot of the other APIs. There is a get API verb for getting alerts. This is going to be a list. This is going to return a JSON array of the alerts that match my query. If I supply no query, I get an empty search parameter, which means all alerts are returned. It's important to note that this is always a list of the slim version of the alerts. And so you're going to see this pattern again and again throughout the API, that if I want to get the details of a given alert, I first retrieve the list of alerts that I'm interested in. Within that alert, you're going to find a unique ID for that alert, and then I can go back and query using the get alert path, which provides the ID as part of the URL. So again, this pattern is going to happen again and again. If we retrieve deployments, for example, you wanted to get the unique ID for a deployment, you would retrieve that from the deployments API endpoint, get a list back, parse through the list. If you want to retrieve all deployments or all alerts or all images, again, the same pattern. You're going to retrieve the slim list, you're going to get that ID out of there, and then you're going to use that ID to loop through every ID in the array that's returned to go and retrieve the details for all of that. So you're going to see that pattern again, and we'll look at some examples of that a little bit later. Now, to use the API, I mentioned that you need to have authentication. Let's go ahead into the platform configuration integrations menu and create an API token. So we're going to scroll down here to past notifiers, past all of the cloud integrations, and go down to the API token section here in the bottom. Now I have a couple that are already created for CI integration and for general admin purposes. Let's go ahead and create an API read-only token here. I'm going to choose a role called analyst because I know that's a read-only role. You can create custom roles. You can use built-in roles. For example, if I'm going to use this just for doing things like image scans, I would use continuous integration. Obviously here, the least privilege principle is the best approach. You can choose when these expire. If you don't supply an expiration date, they're going to be 1 year. So I can choose to make this, let's say, a 2 year. I can make it shorter. I can make this expire, in 1 month from now. Either way, these are fairly, these are going to be, they're going to expire on a particular date, at which point they will no longer be used. They're actually not going to be deleted. There will still be a record of them, but they will not be available for use after the expiration date. When I go to generate this, you're going to see I get the text of this that I can copy to my clipboard. You will not be able to access it after you close this window. So it's not stored by ACS. It will not be retrievable from the ACS API or anywhere. You must save it. Now, if you miss that, that's fine. You can just create another one. These are disposable. So go ahead and copy this to the clipboard, and then we'll get ready to use it in our API client of choice. Let's take a look at a few basic ACS API examples. I'm using curl format here, but the same rules would apply for any client that you might be using. One of the most basic things is to be able to retrieve alerts, also known as violations. To be able to do that, I'm supplying an endpoint here, just the host name of the central endpoint where this is hosted, and I'm supplying a header labeled authorization bearer. This is the bearer token that's used, in this case using the API token from the earlier UI creation page, and I'm just simply supplying that to curl as part of this. Curl is making an HTTPS request by default and returning us the raw JSON. This is seriously truncated here, but you're basically going to see an array of alerts, right, indicated by the square brackets. Each one of those alerts is going to be a slim version of the alert, which has an ID in it. In the next example, we're going to filter that list. So instead of getting all of the alerts, we're going to supply a query that actually limits what parameter we search for in that alerts list to restrict the amount of data that's returned. This is a really good practice. If you're looking for results for a specific namespace or you're looking for results for a specific policy, this is a good way to filter the amount of data that has to be processed after it gets returned. Either way, I'm getting back the same format, a list of alerts. That list of alerts needs to be parsed through if I want to get the details of that for each individual one. The queries are pretty flexible. So a lot of the endpoints that would otherwise return a huge amount of data, like deployments or alerts, can save the amount of data to specifically what you're looking for. And there's a lot of different ways to specify this. You can see, for example, the readable version at the top here just supplies a query that includes a particular namespace. I can actually comma separate multiple namespaces. You could, of course, use URL safe encoding. This is a little less readable, but it's a little more friendly for the systems that you'll be using to retrieve this. Avoid having to use quotation marks to escape those items. Filtering by policy, again, you're going to see this is URL encoded here with the %20 indicating a space character. But this is looking for fixable severity, at least important. In other words, it's violations of a vulnerability scanning policy to give me back those results. You can also combine. The queries can get quite complex. It follows roughly what you'll see in the UI when you can create filters to restrict the amount of data. Here, in this case, I'm looking for just the results from two different namespaces in a cluster called prod. Now back to alerts. In my slim list of alerts, I had IDs returned in a list format in JSON. If I go back and loop through those IDs or pick a particular ID and supply that to the endpoint, I'm getting the ID here, the details of that specific alert. Here, you're going to see a lot more information about the policy that was violated, the deployment and all of its attributes and characteristics that were the cause of the violation. You're also going to see for runtime, for example, you'll see process data or network data that caused that runtime violation, or in the case of vulnerability policies, you'll see the details there. So this is a really thorough, it's the complete forensic results of any of the data that led to the policy being violated. This is a good way to get data out about specific violations. You can also check the status of a given violation. A violation could be in an active state or in a resolved state, and the JSON output will tell you that. Now, to go the other direction and submit data, we're going to change things a little bit. We're going to use curl with the post verb. We're going to post a policy here. Note that ACS for endpoints supports different verbs. There's sometimes things like patch for modifying an existing object, but here we're actually going to create a new policy altogether. The JSON data here is encoded in a file called policy.json. A good way to do this is to start by exporting a policy from the user interface to see what the result is. Or if you're creating a new policy, create that new policy in the ACS UI and then export it. That way you're not fiddling around with all the JSON. ACS does the work for you there. There's also a dry run process for creating new policies. So in the /v1/policies endpoint, you can append /dry run, and it will tell you about any issues with the policy upon import. So if you had a clash of names, if you were missing a field, you would see those errors before you actually attempt to create that. In the case of a successful post, you won't get an error back. You'll get a 200 series error code back that indicates success, and you'll get a summary of the new policy, including its new ID. Policies have unique IDs. They're assigned by ACS once they are imported, and so you'll be given back that new policy ID for your records. Okay, let's take a look at some live examples. I'm using Postman here, which is a RESTful API client. I've created a collection called ACS under my workspace, and I've defined a couple of variables. I'm going to put the host name that we're contacting, which is the host name for Central. In my case, that's hosted in Red Hat Cloud because it's part of the ACS Cloud service. So that host name goes in a variable called Central. And then, of course, the StackRox API token that we need for authentication. Under that collection, I've created a request that is called Central. I'm actually going to be requesting the V1 alerts endpoint. I'm using Central as the host name here. And then under the authorization section down here, I've gotten a bearer token choice. You can see that I'm supplying the token with the value of ROX API token here. I don't need any other parameters. I could define things like MIME types. Again, we're going to be sending and receiving JSON here only. So we're just going to keep it simple. When I request this, you'll see that it comes back with some JSON. Postman will forward that for me. And like the examples that we saw earlier, I can go and retrieve an individual ID. So remember that endpoints like alerts and deployments and images returns an entire list that is truncated. The values of each object here are slim. And then if I want to get the details of that, I can just simply put in that ID and retrieve that where I'll get the full details of it. In this case, policy called missing image signature. It's going to give me details about the deployment that is violating that rule. Now, if we just go back to the default alerts endpoint, again, this is retrieving all alerts if I wanted to filter that. And this is a good idea to do this to keep the amount of data that's coming back from the server lower. Let's say I'm just looking for a specific namespace. I can put that in here and just retrieve a particular namespace. This is also especially valuable for retrieving the violations for a specific policy. So if I'm just interested in vulnerability violations, I can retrieve just the violations by retrieving for the policies that are filtering for those violations. Okay, let's talk about some advanced API topics. First of all, let's talk about the ACS UI again. The ACS UI uses the RESTful API, and so it's a good idea to look into how the UI uses the API when you're trying to duplicate something similar. If you're trying to retrieve data or to submit data, especially, it can be difficult sometimes to understand what kind of data is required, what the JSON format is. And you can use the developer tools in either Chrome or Firefox to go and actually see these payloads being transmitted by the browser to the ACS UI. We'll see a demonstration of this in the next section. Another topic here is pagination. Many of the API data retrieval API endpoints are going to return a lot of data. Alerts, deployments, images, these might return thousands and thousands of entries. Pagination limits how much data gets sent back, reducing the load on Central and on your API client. There's both an offset, which defines which record to start with, and a limit, which tells you how many records to return. Pretty simple. Pagination also supports sorting options. So you can specify how you want these to be sorted when the data comes back to you. Again, saving time and effort, some of the logic on your side. Let the API do it, let Central do it. By limiting the amount of data or making at least the amount of data retrieved from Central predictable, you'll improve performance and reliability of your scripts. The last topic to talk about is exports. So if you do want all of the data, there is some new bulk export endpoints here. These are shortcuts to the endpoints that provide data without any filtering options. So you won't be able to limit the amount of data that comes back here, but if you're looking to post-process all of this for an external system, like all of the data about images, including their components and any vulnerabilities, this is the way to go. These exports reduce the amount of load on central because they're more direct dumps of the available data. Okay, so one of the things I want to show you with ACS is using the developer tools in Chrome to query what the ACS UI is doing with the ACS API. So if I browse to the developer tools and over to the network tab, we'll see all of the data that's being transmitted back and forth. As I refresh, you can see all of the activity from the browser to the backend to central. If I look at something like violations, for example, you're going to see that very familiar endpoint. We're down here, we're using the alerts endpoint, in this case with a query attached to it to provide pagination, offset, and limits and sorting. And I get back, of course, a list of JSON alerts. This is that slim list. As I click on an individual one, you're going to see that another request is made to a specific alert, and you can see the results that come back from that. Now, to go the other direction, where the developer tools can really be helpful is in creating a configuration like an integration. Let's create a generic Docker registry. Sometimes these can be hard to figure out from the documentation exactly what's required. So let's create an integration, and we'll just make up some values here because I'm not actually going to use this for anything. I'm going to put some fake username and password in here, and then I'm just going to create that. And we're going to watch over here the image integrations endpoint get called. Okay, again, this is a post, so we're sending data, and the payload here looks like this. This is really useful if I wanted to create these automatically. To be able to take this data, I can copy the values out of here. I can change the values as appropriate and then use them to submit results. And you can, of course, see the response to that, which is actually that ACS has assigned a unique ID for this integration and then provided me with the feedback for all the data that I provided to it. All right, in summary here, the ACS API can be used to perform almost any action that you see in the ACS UI. You can retrieve data like about violations, also known as alerts, about vulnerabilities and images and deployments. You can also configure ACS through the API by posting data to one of the API endpoints. Recall too that RockCTL provides a lot of capabilities. And where it provides those capabilities, you should prefer using that to automate versus coding your own in the ACS API. So for things like image checking or backup, take a look at RockCTL and the capabilities that it has. The ACS API always sends and receives in JSON format, and every request requires authentication using an API token supplied in the authorization header. This is a bearer token. Lastly, you should use the query parameters and pagination, or both, in order to reduce the amount of data that gets sent back for any one request. This means less data for you to process at one time in your custom code, as well as reducing the load on central for the amount of data that it has to process. I want to thank you for your time today. Look forward to seeing you on the next ACS Snapshot video.